I'm Ana Villamor, so I'm team lead in Power Electronics in the Power and Wireless division in Yole Intelligence, that is part of your group. And I'm happy to be presenting again in this edition of Tektronix Innovative Forum. I hope that you will enjoy the topic that we chose for you in this edition, that it's what is driving the power electronics market. So we will having, yes, the slides here, and there will be a focus on system and device level. So the presentation will be segmented in 4 parts, basically. So there will be a short introduction on megatrends, system technology trends, and the impact on device choice and device market, and then a small part on supply chain. So let's start by what is driving the power electronics market. So there are many governmental discussions about decreasing the CO2 emissions, decrease energy consumption to be able to decrease the use of electricity, as there is so much electrification ongoing and sustainable energy generation also. And this is a hard task today in a world where we have more and more electrification. So we have the electric vehicles, including the bus trucks, big tractors, also on mining, and also coming the e-planes, so many electrification ongoing on transportation. There is also batterification, so meaning more battery-powered systems. We can talk about, we have robots in home appliances, also we have these in consumer electronics, also in drones, also for agriculture. Also on this digitalization, so everything more connected, more control, more functions that will bring system efficiency. Here we have Milwaukee was giving a presentation a long ago on these power tools where you can control everything by your phone, having all different functions and even looking for where it is your tool if it's stolen, for instance. We have also more sustainable solutions, so more renewable energies, so PV, wind, more efficient buildings and factories that will also help to have these sustainable solutions. And what we talk about call integration, so more synergies between different applications and integration trends, which means synergies between PV and battery energy storage, and then integration trends within the same application. And I have a slide later for that one. So there are many applications where we can find power converters. We have low power, high power, and none of them are the same. But in the next slide, I will try to summarize some of the trends that we can find at system level for power converter. So here we have different trends, as I was saying. At the very top, we can see higher integration. I have a slide later for that, but it means high integration of the same system or from the same application. So here, for instance, we have a DC-DC and onboard charger integrated in one single system. Going to the right, we have increase in power level. We have for an example, we have a DC fast charging of 350 kilowatt, but we see different players also in China going to 410, 460 kilowatt. And at the same time, we're going down in the circle, we have a decrease in power level and in the same application even. So this is why it's quite different to have an overview of all the trends together. So as an example, I choose also the DC charger. We have a trend to go to lower power for DC charging. So here we have an example from Ugreen Power, 7 kilowatt bidirectional DC charger. And this means that on the car directly you will be connected to the DC, and even the onboard charger will be eliminated from the car. And already there are some model in China from an OEM that it's been launched without onboard charger. If I go to the left side, we have here left top, we have hybrid solutions. I have also a slide on that. When we combine in one single system different applications like PV with energy storage or DC charging. Then we have other trend that is to use more and more modular systems, not only for high power, but also for low power. And I will have also a focus on that. More intelligence, more functions behind, and higher efficiency. And this is also achieved with wide bandgap materials, so using silicon carbide and gallium nitride. So I have focused on some of the trends. So the first one is towards larger installation. So we have seen PV and wind going to more than 1 gigawatt installs. DC charger on up to 20 megawatt, and BSS also higher than 100 megawatt. This means that when we had megawatt, we're going to gigawatt. When we had kilowatt, we're having now megawatt installations. So having many more modules, many more units, or higher power units on there. Second trend that we can find is going to a higher converter power that it's linked to the previous one. And this, it can be also taken not only for renewables, but also for consumer. The first one on the list, this is USB charger that in the past we used to have 60 watt, and now we are more at 120 watt. Same for string PV inverter that we were at 60 about, and now we are at 250 kilowatt. On the central inverter also, increasing from 2 to 3.5 megawatt solutions that we can find today. On wind turbines from 5-8 megawatt, we see now systems much higher power than that, and this is basically on offshore wind. And we also have energy battery storage that it was about 1 megawatt, and now we see installs of 5.5 megawatts. So the high power, there are different things that are becoming critical. That is the current level, there are the losses and the reliability. And this is going towards a higher voltage and more modular systems. And this is what the next slide is about. So this modularity, we see that more and more modular systems in there. So we have higher system efficiency and more redundancy. There is a higher system design flexibility, more dynamic power allocation. This means that, so this is an example. So if we have a 100 kilowatt charger, we can use this 100 kilowatt to charge one car. But then if it's modular with some intelligence behind, we can just use this 100 kilowatt to charge different cars. So having 50-50, or it depends on the contract that they have with the energy, with the electricity provider and others. So we can achieve also with the modularity more scalability. It's quick and easy to build. We can have some cost saving because a lower power, we have more offer on components also, and then there is more choice. So ASP also can be lower than if we have only a 350 kilowatt systems, for instance. I'm just thinking on the DC charger. And it's easier to maintain and to repair because just one module that was broken, you just replace it with one another module, so it's less costly to replace it. So now I come to the hybrid solution. So there is different applications that they can go together. So here we have some examples like the PV with the energy storage. We have also EV charging with energy storage, or PV with the DC charging, and even we have solutions that are even pushed further when we have 3 of them, where you can have your PV, so you have your renewable energy source, you will have your DC charging, and you also have the battery at the same time. So you have 3 systems in there, and this what brings you. So you can have like one stop shopping. So everything, all the systems will be from the same provider. You can have product differentiation, so it's nice for the converter maker to have this kind of solutions. The weight, the volume, and the cost can be minimized on the system level. And when we go to the device part, so device level, we can think that the topology can be changed, because instead of having 2 different systems, we can have a different topology, and then we will have a less counting of components, because we're using the same converter for different applications. And the last trend that I wanted to discuss about is about integration. So the main reason of integrate subsystems is to improve the performance and to reduce the system cost. So integration will lead to the weight and volume reduction, and then we can have also higher power density in here. The thermal management can also be optimized, so having a different cooling, smaller or lower cooling cost. And then we have a full cost reduction of the system, and the wiring also can be shortened, so you also have less loss on your system. So there is a lot of push for integration. And one of the main examples, I go to next slide, is on the BEV, so on battery electric vehicle. So here in the schema, we have two lines. So the green one, that is a signal, the power that is in blue, and we have different systems. So today, the main trend is to have the integrated power unit when we will have, so PDU, so power distribution unit, DC-DC, and onboard charger. This Eton, for instance, is already doing this kind of solution. And then the E-axle. E-axle is what we call inverter plus the motor plus the gearbox. And these NEO, for instance, or NIDEC are already doing this kind of solution. These are the most used ones today, but there are other ones that is also integrated in different systems. What we have, for instance, the extended battery pack. So it will cover almost everything that is not a battery pack, having the PDU, DC-DC, onboard charger, inverter, and motor. And this, we have Huawei and BYD that is already having this kind of integration. And last, we have another example on a Tesla. What they are doing is to have complete the battery pack, the PDU, DC-DC, and onboard charger in one system. So you see that there are many integration trends. It's a very small space where we need to compile many systems. And that is really interesting on the EV to have a lot of integration. So maybe here to come to the converter market overview, I just want to point some of the applications here. We have industrial that it's taking a lot of value of the converter market. This is we have a lot of systems where we have a lot of units like these warehouse robots, security cameras, small pumps, forklifts. And there are some of the systems that are less units, but big power, some equipment and so on that need big power and they are really costly. And this is why we have this high, so the mix of them, we have this high market here. So the most maybe exciting application will be EV because it's the most growing on the next years. Here we need to think that the system, so the most costly system, it will be an inverter and it will be about $600, $800 max today, even if using silicon carbide. So we expect this market going even almost to $25 million in 2028. Another nice market is in PV. So this is keep on increasing. We have seen just in previous slide that we have more and more installs on big size installs. Same for wind. Also in DC chargers, so the growth is nice there. Here we use a lot of modularity. So basically when we have this 350 kilowatt, there will be between, normally it's 50, but some of the systems also use 30 kilowatt. So you will have different modules on there. And basically you will use discrete components here. And another application that is quite interesting, I think in the future will be even larger than this, is BSS. So as we were saying, everything is being connected to batteries. Once the cost of the battery will be decreased, this market will be even larger than that. So how this is translated to the device needs. So there are different factors that are determining the device choice, but generally speaking, it comes from the application drivers. So it will give you the lifetime, reliability, which efficiency that you're needing, the system characteristics, operation temperature, the power density, the cooling system that you want to use, the size that you have there, low power, high power. And this will give you the input to your device characteristics. So which voltage you need, current, which size, which packaging. So it's a module, discrete, system package, system in chip, and which material do you want to use also on gallium nitride, silicon carbide, or silicon. So not all the markets, all the applications can be done on all of them. It will depend really on the system characteristics and the application drivers and requirements. And of course, cost is a common factor of all of them. So here we had a slide with the different markets for devices. I want to distinguish between high efficiency systems that are being pushed. Here we will have gallium nitride and silicon carbide. So we have on the left side 2022 market on GaN discrete, SiC discrete that are increasing to 3 and 2% respectively. And the module, silicon carbide module, it's a 5% in 2022 and it's increasing to a 20% by 2028. This is mainly driving by EV. Take into account that this is a value market and cost of silicon carbide is still some more expensive than IGBT. And this is why also we have this big growth on silicon carbide. Then we can check also on IGBT module. This is a big market, so big part for it is on the UPS, on the PV, on the big installs, on wind, also in EV, so not the full market. It's not on silicon carbide, of course. But we have a slight decrease on the market on IGBT module on percentage because of the value of silicon carbide. Again, it's taking shares from that, but it doesn't mean that the market in value will decrease for IGBT module, of course. And then there is the MOSFET discrete where we have a bunch of 600, but also 40 volt components. Mostly of them are used on consumer applications or in automotive. There is a huge demand also on 40 volt components for automotive. But then here also the ASP is a bit decreasing. So it's not surprising that the MOSFET market is decreasing. Also because some of the, for instance, on the onboard charger, when we used to have a silicon carbide, we used to have silicon device. Now this will be in silicon carbide, and in the future, some of them, it will be even in gallium nitride. So I wanted also to share with you this slide when we see the difference on discrete and module. Again, just to emphasize, when we go to module is because we have higher power levels. You see we have an increase of 11% on the module market, meaning that we're going also, as we were saying in the previous slides, driving for a high power systems. And then on the discrete part is mostly on this 600 volt, 40 volt, where ASP is also decreasing. A consumer is not highly increasing market. Auxiliary on the car, yes, but the ASP is also kind of decreasing. So we will not have a huge increase on discrete part in here. But really the big focus here, or the big push here, is on the EV that is driving the module market and this growth on revenue. Then we have this slide on diversification of power components, semiconductor materials. So we have the silicon-based silicon carbide and gallium nitride on wafer, which is the starting material. When we have gallium nitride, this can be on silicon, but it can be also on sapphire. Today, commercially, we have, so on silicon, we have the diode rectifier, the bipolar, MOSFETs, IGBTs, thyristors. For the SiC wafer, we have the SiC diode, SiC MOSFET. And on gallium nitride, we will have the HEMT and the GaN IC, which means that you will have, or GaN IC plus the HEMT. So having the driver or different functions along with the HEMT in the same chip, or sometimes in different chips, so system and package or system and chip. And in development, we still have open road for different components that could bring more efficiency. So in silicon, we still have silicon superjunction IGBTs, for instance. There is some research on that. On silicon carbide, we can think on silicon carbide IGBTs. And on GaN, we can think about the GaN diodes, and also on vertical GaN that it will allow higher, even higher voltages, because today with the lateral GaN, we're quite limited on voltage range. So there is still a growing path for power electronic components. And today I wanted also to show this graph with the vision on the different components. So in silicon, so materials, substrate materials, silicon, silicon carbide, and gallium nitride. And we see that the silicon market in value is decreasing. That might not decrease so much if we look it on million units. So the silicon carbide is including discrete and modules, and basically is increasing for both sides a lot, of course, because of the module, because of EV application, but also for PV, also for discrete parts that we can find in the onboard charger. For the onboard charger, for instance. And then we can see on the gallium nitride a small growth also here. This is basically only taking into account the HEMT, not comparing here with all the IC. So it's only taking up one part of the consumer. That's a trend to use the gallium nitride on the fast charger. And also we see in the future some penetration of gallium nitride for datacom. And we see more and more push for onboard charger and for even main inverter after 2030, I would say. So it's still long term, but there is a lot of interest of this technology. And yeah, this slide, what I wanted to show is the system voltage and component voltage, and that we are having new choices on voltage side. Starting from the bottom part, left bottom part of the graph. So when we have a 400 volt system voltage, normally we use 600, 650 volt devices. Today, when we're thinking about BEV, so battery electric vehicle, batteries, we say always 400 volts, but they range from 350 to 480, 500 volts. This means that we will need even higher voltage than that, not 650, but maybe 750 or 800 volts. And we start to see the demand on these different ranges. And the same, it happens, for instance, when we go to higher voltages. So normally we had this range on 650, 1200, 1700, 3 to 3. But now we see more and more intermediate voltages when we have the PV. We are going from 1200, used to have 1700 volts. Now we're going to 1500 volts on the system level. You see that the solution is only a 3.3. And many players, what we see is that they are having now solutions on 2.5 kilovolts, sorry. So to do not have this really big margin that you will be losing on efficiency by using this high, and in cost, it will be more expensive on that. So now the converter maker can choose to have or a standard voltage range or an intermediate one. It will depend, and ASP also will be depending on that. And with this, I wanted to show you the forecast on the different voltage levels. So again, we are showing here the value market. What we see is a huge increase on 1200 volts. This is very push for the EV because of the EV 800 volt battery will be using 1200 volt devices. And then you see that the 17 and higher power voltage levels, they are quite at 3 and 4%, but see that the market in value is increasing, meaning that these markets in value are also increasing. That's what also we were saying at the beginning of the presentation, increase of voltage levels in there, on power levels also from the systems. And we see a small decrease on both 640 40 volt devices, but this is mainly because of consumer is not hugely increasing, and then the ASPs are also decreasing on that side. So there is a lot of competition, and we go also to 300 millimeter that will provide lower cost for that components. And I wanted to give you some thoughts about manufacturing, if I allowed myself. So on the converter manufacturing, in fact. So we always focus on the power module, on the discrete part, but we need to take into account that there are many components that are taken into account for the full converter assembly. So we have passives, we have bus bars, current sensors, cooling, even the housing of the converter, and many power management and microcontrollers. So all of them will have an impact on the assembly. And if any of that parts are not available, we will not be able to launch our system. So this happened not long ago with an OEM in China. They did not had MLCC capacitors, and they were not able to launch few thousands of cars. We had also the example for a few, I would say now years ago, when we had this big shortage with MCUs. Cars were not able to be manufactured because we missed all the MCUs. So there are different stages before the assembly can be done for all of them, of these components. So for manufacturing, we need the starting material. This sometimes is tough to get it, and the ASPs may vary a lot. We need to test the material properties in most of the cases. We have to keep on doing R&D, so some testing also needs to be there. Manufacturing line has to be available, and we need also capacity for all of them. So it's not only on the wafer, only on the chip, but also on the packaging and also on all the other systems afterwards. There is testing also capabilities. We're increasing number of fabs, and the testing equipment also will need to be increased because more devices will need to be tested, of course. Then there is the assembly of the converter, and then test of this converter, which will be also increased. So yes, we have an increase of market, but everything has to follow. All the components, all the testing, all the equipment, all the manufacturing lines. And with this, I wanted to go now to the takeaway. So we have seen different general trends. So basically, sustainable trends, electrifying everything, and having more energy efficiency. And in the technology trends, what we have seen is that we have higher power systems, but also installations for different, we have seen it for PV, for wind, BSS, DC charging, using modularity, not only for high power systems like wind, but also for lower power like DC charging, and having a lot of integration. And this is a lot driven by EV. So we have a market that is keep on growing on the power electronics. There are multiple growing markets. The fastest growing, of course, is EV. But then we have a large number of million units on industrial, on consumer, and home appliance and other applications. Also on renewables is quite important. And there will be a lot of push next years to have more and more installs on that. And last but not least, so on the supply chain, so needs to be secure from the different points of view. So it's not only about the component, but the full system, passives, everything has to be taken into account. So with that, I finish my presentation. If you need more information on market, supply chain, technotrends, this you can check in our reports, or you can just drop me a mail. I have here to contact. I'll edit you just a second. And I will be happy to respond to you and to have a discussion if needed. Thank you very much for your attention and have a good day.